Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to look at graphing polynomials. What do we know? How can we decipher a graph and find the equation that may result in that? All of these things. So I want to draw your attention to what we did with quadratics because that's, along with a straight line, are the easiest type of polynomials that we can plot. Remember, we said that if the leading coefficient, which is the coefficient of the highest power, which we call the degree. So the degree of a quadratic is 2, and then the leading coefficient is the multiplier of x squared, which is the letter a when we say ax squared plus bx plus c. So this is the degree, and this is the leading coefficient. We said that if the leading coefficient is positive, our parabola is opening up. And if a is negative, it's opening down. So now we're going to expand on that a little bit. Okay? So the first thing you are going to do in any polynomial graph is to look at the leading coefficient. If it's greater than 0, we say that the right end is going up. You say, but both of them follow each other, so why do I say the right? You will see in a second. And if A is going down, I'm sorry, if the graph is going down, then A is less than 0. Okay, let's agree on that. And that doesn't conflict with this, right? If A is positive, it's going up. These we call them the end behavior, right and left. So the right follows the sign of A. If it's positive, it goes up. If it's negative, it goes down. Secondly, the second thing you need to know, if the degree is even, like in a quadratic or x to the 4th or x to the 10th, then left follows right. Oh, so because the quadratic is square, which is even, then the left is the same as the right. I will get that. Yeah. How about if the degree is odd, then the left would be opposite to the right. So if I have ax cubed plus bx squared plus cx plus d, and if a is positive, I get something that looks, first of all, remember we said if it's quadratic, it can have two curves. So I will see the right-hand side is going up, and then there is a curve and another curve. And because of that, the left is negative or going down. If A is negative, then the right-hand side is going down. There is one turn and another turn. And the left-hand side is opposite, and that's why the left-hand side would be opposite to the right-hand side. So two things you think about. First of all, is A positive or negative? Positive, I know the right-hand side is going up. Negative, the right-hand side is going down. Then the degree, is it even? Follow, match each other? Odd, opposite to each other. So I know now the end behavior of graphs easily. One more thing. Remember when we also were talking about the quadratic, and we said we have three cases. Okay, three cases. Well, let's look at the when it's A is positive. It's the same thing for it's negative. We say if A is greater than 0, you get two solutions. If A equals 0, you get a single solution repeating. And if it's A less than 0, I don't get any solution unless they are complex answers or it has it has an imaginary part. But I'm interested now in trying to understand what's going on here. If this point is b and 0, then it says one of the solution is repeated. Meaning it is in the form x minus b quantity square. Why x minus b? Because if b is an answer, if x equals b, then x minus b is one of the factors. Remember, we get the factor and we say equate it to 0 and then solve. Okay? So if it has an even power, or even power meaning 2 or 4 or 6, in our cases, most of the time we'll see 2, right? Square. It means that the graph doesn't cross the x-axis. It barely touches it and then goes back. Even if it's going down, it would be touching and coming back. But if it's odd, it will cross. Odd crosses even, that's the in the power. Bounces back, bounces off. And having said that, I think this covers everything. The sign of the A is the leading coefficient. So the sign of the leading coefficient, positive meaning right-hand side is going up, negative meaning right-hand side is going down. The degree is even, follow each other. Degree is odd, they are opposite to each other. The root appears once, you cross. Appears twice or 4 times or even power, it hits and bounces back. Easy? Easy peasy. Okay, let's look at these examples and see if we can solve them. I'm going to leave the number 118 for now for a second and then move to the next one because this one is not it. This is about factoring. So I'll go back to it. This is as a review of last time. But if you go to 119, it says a sketch for p of x, which is this function. What is the degree of that? Two curves, degree is 3, right? A is positive and B is positive. Okay? If A is positive and B is positive, but I have negative A because it's on to the left of the y-axis or the P of x, and B is positive to the right. Then I may have an x minus B factor for this, but what about this? If you say x plus A, you're incorrect. Because what else is happening? It bounces back. So there is x plus A quantity square. Not only that, the right-hand side is going up. So if there is a coefficient, so if this equation is, for example, negative 2 times x plus A square plus x minus times x minus B, it would be incorrect. It has to be a positive leading coefficient. Notice if there is nothing, if I just multiply those two, the highest or the degree is 3, and I get x cubed, right? X squared times x is x cubed. It's positive. So that works. Now let's look at that. This one doesn't have a square. This one has a square. That is the one we are looking for. X minus b and x plus a squared. So it's number 2. See how easy it is? 3 things you are looking for. What is the right-hand side? Where does it cross and where does it bounce back? Let's look at this. The graph of a cubic polynomial is shown below. If p of x is written as a product of linear factors, which factors would appear twice? Meaning it would be squared. 1, 2. So x plus 2 quantity squared. Here is x plus 2, and it would be appearing twice. Easy, right? Move to number 3, or 121 in this case. The graph of the function p of x is sketched below. Which equation could represent p of x? I'm crossing at 2, at 3, and at -3. So it would be x minus 2, x minus 3, x plus 3. Huh, nothing like here. Oh, but I have 3 positive and negative, meaning I have x minus 3 times x plus 3. This is x minus 3, this is x plus 3. Oh, a plus b, a minus b. That's the difference of two squares, which is x squared minus 9. And this one is x minus 2. Okay, x squared minus 9 times x minus 2, it's number 1. I don't have to worry about the rest. Okay, this is x squared plus 2, so it's not correct. Here, you can waste your time and try to factor them, but at the end of the day, you know it's only one answer and we already found it. Okay, let's move to the next page. 122, a sketch of r of x is shown below. It crosses at a, there is x minus a. It crosses at negative b, so there is x plus b. It doesn't cross, it bounces at c, so x plus c quantity square. These three have to show up. Those don't have squares, 1 and 3, but 2 and 4 do. Okay? X plus c square is 4. Here it tells you x minus c square. No, if it's x minus c, it means c is here. Because when you solve, you'll get x equals c. So we know that it is number 4. Again, which function could represent the sketch below where a, b, c, and d are all positive, integers greater than 0? Notice this is negative, so I have something like x plus a, and I have, it doesn't matter, it's negative b over c, so it's x plus b over c. And then this is d, but it bounces, so x minus d, because it's to the right of f of x squared. First of all, I have x minus d squared only in number 1, so that must be the correct one. And you say, and notice it's going down, so there is a negative sign, which is here. All of them have negative signs, so, but you have to be careful on the right-hand side because they may give you two of them, one with and one without. If it give you without, it means x times x squared is positive. But if you multiply it by negative, you get the right-hand side going down. But what about this thing? What about it? Yeah, you can multiply outside by c. If you multiply outside by c, you will get negative. First of all, if I multiply the whole equation by c, notice that this equation equals 0 to solve. So if I multiply by c both sides, the right-hand side would still be 0, but the left-hand side would be cx plus b times x minus d squared. And that's why you have cx plus b here. So it's number 1. Okay, write an equation for f of x. This is third degree because it has two graphs. The right-hand side is going up. So I can say f of x equals, it crosses at -3. So x plus 3. And it bounces at 1 times x minus 1 quantity squared. And they tell you the leading coefficient is 1 because I was going to tell you, and here you can have any constant multiplied by that depending. But since they tell you the leading coefficient is 1, when I multiply these, eventually x cubed coefficient would be 1. There is nothing multiplied by x here. There is nothing multiplied by x there. This would be x plus 3 times x squared minus twice x plus 1. So when you multiply the x by the x squared, you get 1x cubed, right? And it's positive, so there is no negative sign outside. If they give you the same thing flipped over, you have to say minus here because the right-hand side would be going down. Okay, last two problems. In 125, they give you this equation and they say a and b are both positive values, meaning I'm adding a, so a is to the left of the y and b is to the right. It passes through b, it bounces at a. Positive, all these two are going up on the right, so they could be the correct answer. This one doesn't bounce at anything. It passes through 0 and a and no. So it must be this one. Okay? It's number one. It bounces at A, it crosses at B, and the right-hand side is going up. Last one. Which graph represents a polynomial function that contains x squared plus 2x plus 1 as a factor? Perfect square. X plus 1 square, meaning bounces off at x equals -1. I look at -1. This one bounces back. At -1 crosses, at -1 crosses, at -1 crosses. So this is the only one that bounces back at x equals -8. And that's how easy it is to find which type of graph will have these factors or, has those factors or whatever the problem with it today. I told you the first one, I will talk about it later. So maybe if I solve it on the back here, let's look at this one. It says z of x equals 6x cubed plus bx squared minus 52x plus 15. And they tell you z of 2 is 35 and z of -5 is 0. Algebraically determine all the zeros. There's only one unknown. Why do they give us two of these? I don't think we need the first one. This one, we know that there is a zero of negative at -5. When x equals -5, meaning one of them would be z plus 5. Or in this case, x, why did I say z? X plus 5. But I need to determine the value of b. I can use this or that to determine the value of b. What do you mean? I don't need both. I may use one and then use the other to check if my answer is correct. And this is important because I will show you something. If z of -5 equals b, meaning every time you see an x, you replace it with -5. So z of -5 would be 6 times -5 cubed plus b times -5 squared minus 52 times -5 plus 15, and that equals 0. So all what you have to do is to use your calculator and solve for b. -5 cubed is -125 times 6 is -750. You can use the calculator, it's easier. And this would be plus 25b. And this is plus 260 plus 15 equals 0. So 25b equals 750 minus 260, that's 490, minus 15 is 475. And then you divide both sides by 25. If I divide 500 by 25, I get 20. This is 25 less, so you get b equals 19. I'm done. So that's why I said I don't know why they need that. Let's see. I'm going to multiply 6 times 8 and leave this for now. Minus 52 times 2 plus 15, I get negative 41. Negative 41 plus something equals 35. So that thing should be 35 plus negative 41 or 76. If I divide 76 by 4, because this is 4b squared, divide by 4, I get 19. So I get the same number. That's why I said, why do they give us 2? I really don't know. Remember, just as an exercise, we are going to use the synthetic division. We can divide this whole equation by x plus 5, right? Because that's a factor. But I said, in order to do the synthetic division, I'm going to write 6, and then b is 19, and then negative 52, and then 15. I'm going to divide that using a z of negative 5. The 6 comes here, times negative 5 is negative 30, plus 19 is negative 11, negative times negative is positive, and 5 times 11 is 55, minus 52 is 3, 3 times 5 is 15, negative, and 0. So I know it's divisible by, of course, they told us this. This is another way of saying that negative 5 is a root. But before I continue, there was something that I wanted to tell you. Sorry, I don't want to jump and bounce back and forth, but I wanted to show you that here we can find something interesting. When I say z of 2 equals 35, it means if I divide this z of x function by x minus 2, my remainder would be 35. Because when I divided by x plus 5, my remainder was 0. So another way of looking at it is to say, I can type any number like a 1. And I say 1 plus 19 is 20, plus 15 is 35, minus 52 is negative 17. So the remainder of dividing by x minus 1 will be negative 17. Or did I say 25, negative 27? Oh, I'm sorry, negative 12, right? Yeah. So that's something we will need later. So now I drop my equation to 6x squared minus 11x plus 3 equals 0. So what was the problem? Did I ask for the factoring or the roots? What did it say? What? Where is the third page? Oh, yeah. It says determine all the zeros. So they given me one, which is negative 5, and now I have to find the other two. Now that's a quadratic equation. It's so easy. I know that I need two numbers that multiply to 18 and add up to negative 11. So both of them are negative, but they are 9 and 2, right? How do I get 9? By multiplying 3x by negative 3. That will give me the negative 9 I want. And the negative 2. Notice 6x is 3 times 2. And negative 3 times negative 1. So now I get 6x squared. Negative 9 minus 2 is negative 11 plus 3. Okay? Equals 0. So now one of the roots, yeah, I say it. Either 3x minus 1 equals 0. By adding 1 to both sides, I get 3x equals 1. By dividing by 3 both sides, I get x equals 1/3. I already know that x equals negative 5. It's given to me as one of the roots. And the final one, if 2x minus 3 equals 0, I'm going to add 3 to both sides and then divide by 2 both sides. and I get x equals 3 halves. I can also use the quadratic formula and we'll get 1/3 and 3 halves also. Okay, so that was it for today. And I hope to see you next time. We are going to go over more material on polynomials. And until then, I wish you all the best. Thanks for your time and thanks for watching. Have a great day.